Okay, so here we're going to be looking at exponential graphs for those of you guys who are interested a little bit about them. First thing to notice with an exponential graph is the way it's written. We call it an exponential because the variable, or the x, is in the power like this. So it's y is equal to 3 to the power of x. Or as an example, y could equal 1/2 to the power of x. But that power, or that exponent, is where the variable is. And when we go about plotting these graphs, we'll find that they do something where they stay level, so they start flat and then go really steep, or they can start steep and go really flat. And that flattening is something that we call an asymptote, so that's a value that it will level off to. It will never get below that value. So never goes below. And that asymptote will depend on what the equation is. So if you're going to plot these things, it's important to think about what we've done before about, getting yourself a few points that you can actually plot for. So you might make yourself a table, x, y, and put it into the table function in your calculator. And you can go ahead and write it if you feel like it, or maybe you can just look at it on your calculator. So plugging them in, what you need to be aware of is that you're going to use 2, then you use the button that looks like an upside down caret or an upside down arrow. So you'd go 2, this is your power button, it's the arrow that points up, x plus 5 is how you plug that into your calculator. So to show you that, I've gone ahead and typed these in, but I'll show you again. So I am in the table function, and I've gone to, my hat button is right next to the exit, that's the power button there, hat, x, remember always use the one under the red button, plus 5. And of course, if you don't have a calculator, you can do these by hand as well. So the other rule that we'll plug in is 0.5 to the power of x times 2, which is what I've got here. I'm just going to go ahead and turn that one off for now, though, so we don't have to see it. And I'm going to go ahead and set my variables here. I notice in my graph I go from -5 to 5 on the x scale, so I'm going to go from -5 to 5 with a step of 1, and see what kind of points I get from my table. So I won't write these down in the table format on a piece of paper because I already have them on my calculator. But I will rearrange my screen so we can see this, and I'm going to go ahead and plot these on here. So remember, these points in the table give you an x, y. So at -5, I'm going to be at 5.0312. Of course, we're never going to get too precise, but that's pretty damn close to 5, so I'll put a little point just above the 5. At -4, well, still really close to 5. At -3, 5 1/8. Maybe I'll skip one. Let's go to -1. I will do them. Okay, so 5 1/4 at 2, and then over here I can scroll down to see a few more. So -1 is 5.5, and 0 is 6. So you can see I'm coming across rather flat, but now watch what happens on the other side. At 1, I'm going to go up to 7. At 2, I'm going to go up to 9. On 3, I'm going to be up at 13. 4 is going to be 21. Oops. 21. And 5 would be 37, which is way off the scale somewhere. So what you can see is that the graph starts really level, really flat relatively, then slowly begins to increase, and then the rate of increase, it goes faster and faster and faster and faster until we get a really steep line. And when you're drawing these, make sure that you put your arrow to continue to show that it continues on and upwards, and again an arrow at the other end to show that it's moving, that it will stay level here. So this is my asymptote on this particular graph. It's 5. My value is never going to go below 5, but that's how I would plot the graph. So let's take a look at the other example that I had. Take a look at our equation. Again, if I go into Menu, Table, I can put both of these equations in here at once if I want, but the trick for you is if you've got more than one but you only want to look at one at a time, you can use the Select button to turn one off and turn one on. So you'll notice if I scroll down, the one that I don't want, the equal sign is not highlighted. The one that I want a graph is highlighted, so that's the only one I'll see. And now you can see that. So at -5, I'm going to be at 64. Well, that's well off the scale. I can't actually plot that. At -4, I'm going to be at 32. Well, that's almost on here. Maybe we can sneak it on there. So -4, 32 might be roughly here. -3 is going to be 16. And -2 is going to be 8. -1 is 4. 0 is 2. 1 and 1. And 2 and 0.5. 3 1/4. So you'll notice, oops, that was in the wrong spot. 2 and 1. Sorry, x of 1 is a y of 1. 2 and 0.5. And 3 becomes 1/4. And 4, we're getting even closer. And at 5, you know, these ones are getting really close to lines. So in a sense, this red equation, the second one that we did, starts off really steep and levels off slowly. So, like I said, these graphs can go in either direction. And you just want to try to, I don't know, sort of connect the lines in. Doesn't have to be perfect, but you're trying to get the idea across that it levels off. Arrows at the ends, and things that you want to be careful about is that you never want the asymptote to drop below the value that it's leveling off of. So here you can see that I'm keeping that red line above the y-axis or the x-axis there. And here on the blue one, the asymptote was around 5, and I'm trying to keep that line from crossing 5. So those are the ideas that we would look at for asymptotes, and one thing that you may have noticed, or may pick up on as you go on, is that when we look at an asymptote, we refer to the number that has the x as its power as our base. So that's the base, and this is the power. The base, if your base is greater than 1, you're going to have an increasing graph, and if your base is less than 1, you're going to have a decreasing graph. So, i.e. this one here, and i.e. that one there, like we looked at. So again, an exponential is not exactly symmetrical. You'll have one half of the graph that levels off someplace, and you'll have another half of the graph that goes really, really steep and will approach kind of a gradient of infinity. It will just get really, really, really steep. So you want to show that in your graph, that you've got a level off on one side and that it gets steep on the other side. And again, just remember when you're plugging things into your calculator, you want to make sure you're using the hat button here, or the power button, that upside down caret right next to the exit button. And that should get you there. If you do need to plug this in, for instance, if you wanted to know what is the value of y when x is equal to 20 or something, on the first equation you would go 2 to the power, you still use that hat button, 2 to the power of 20 plus 5 will get you that number. So you can see it gets really, really big. Likewise, if I did something 2 to the power of negative 15, if you look at your blue graph there, you notice that it actually approached 5. That's an asymptote. It's never going to get lower than that. So I'm guessing that my answer to this is going to be somewhere close to 5. And you can see there it is very close to 5. So even if I did another one, 2 to the power of negative 25 plus 5, I'll get, again, a number very close to 5. And I don't know that you care right now, but something you'll notice about later on with level 2 graphs is this plus 5 here, that's actually going to show you the asymptote. And you'll notice on the red graph, so if this, oops, mark it blue. With the red graph, there's no plus out the back, so you would just assume sort of that there's a plus 0 there, and that would show you the asymptote's at 0. So if there's a plus or minus term at the back, it will tell you where your asymptote is, but you don't need to know that for level 1. You just might pick up on that pattern as you graph these.